Today's code challenge is Prime Fibonacci. Given two numbers n1 and n2. Find prime numbers between n1 and n2, then 2. Make all possible unique combinations of numbers from the prime numbers list you found in step. From this new list, again find all prime numbers. Find smallest, A, and largest, B, number from the second generated list, also count of this list. Consider smallest and largest number as the first and second number to generate Fibonacci series respectively till the count, number of primes in the second list. Print the last number of a Fibonacci series as an output constraints 2 equals n1, n2 equals 100 n2, n1 equals 35.
So in today's code challenge, we needed some of the lab modules. So first of all, import that modules. We have to use the math, and we needed the permutations. So to calculate the combination list. So as per the our problem says that we have to generate a three list. So the first list is prime list first, let it be empty, and another list is prime list 2 second, and third one is the combination list. So we have to take two number as an input for finding the prime numbers between the two numbers. So for that we needed an input that says the number are n1 and 2, input, and we are taking the multiple inputs within a single row. So for that we are using a map function. Now we have to make a list of a prime number between the range of n1 to n2. So for that we have to make a prime list. So let us calculate prime numbers between n range n1 to n2. So as we know, all prime numbers are greater than 1. So let us implement a condition for if I is greater than 1, gets inside and check the condition for the prime number. For that we have to implement a loop for I for J in range of 2 to I. So if J modulus of if I is modulus of Z is equal to 0, then then the number is not a prime. So for that condition we will break the loop. We'll use the break statement to get out from the if condition or condition block. Then if it is not correct, then what we need to do, we need to add the that number, the prime list first. So prime list first dot append I. So in such a way we have got the prime numbers. So as the question says, find from this prime list first, we have to form a new list, and new list with the combination or permutation, using the combination and permutation combinations to make another list, or which have all unique combination of a number from the prime list first. So for that we have to make, we have already made the combination list. So let us implement a form permutation our prime list first. We need we need to take a two number at a time to calculate the number of permutations can be, or a unique combination of number can be formed from the prime list first. So as we got the total number of the combinations of number from the prime list first, so let us make append that, or add that numbers of from combination of numbers from the prime list first to the combination list. For that we are going to using an for loop. In such a way we will in such a way we will add the number to the combination list. combination list dot append and now so as we have made two lists, now we have to create the third one list which will have the prime number, and we have to sort out the prime numbers from the combination list. So for that we are using the same method in which by which we have calculated the prime numbers between a range of n1 to n2. So now in such a way we have added the all the prime numbers from the combination list to the prime list second. Now as a as a we have done the permutations, and so the list contains some of the elements which are repeating. So to make them avoid them, we have to make in such a way we can remove the repetitions of the same number prime numbers from the prime list second. In such a way we have made prime list second. Now we have to calculate the maximum and minimum or largest and smallest number prime number from the prime list second. So let us say smallest is equal to min of prime list second, or largest is equal to max of prime list second. So we have got the smallest number and the largest number. So in last step we have to create a Fibonacci series which having the starting two numbers as a smallest and the largest. So let us start with the Fibonacci series. as the initial number n1 of the Fibonacci series is smallest and n2 is equal to largest, and we have to calculate the Fibonacci series till the count of the length of family second. So let us start with it, forming a Fibonacci series for I in range to n minus 1. Nth term is will be equal to n1 plus n2, and n1 term will becomes the n2th term, and n2th term will become nth term. So in such a way, we can calculate the Fibonacci series, and as an output, we have to print the last digit of the Fibonacci series. So it will be n1 for particular range. Let us initialize the nth is will be 0. So let us run it and test our cases. We are taking the same example. As split is a function. One more. Now let us run it. As you can see, the we have created the same output and the program has run successfully. So in such a way, we can solve the following problem of Prime Fibonacci series